Good day, everyone. Welcome to I Square Maths Academy, where numbers and variables actually meet mastery. Today, we are going to be looking at simultaneous equation involving tens and unit digits. That is, word problem leading to simultaneous equations involving tens and unit digits. Now, let's look at this. Yes, let's look at this. Now, when you have two numbers like this, or let's look at, yes, 55. Yes, this is a number. 55 is a number that actually involves two digits. So here we have the 10 digits, and here we have the units digits. So you call this tens and units. Now, if you have it like this, 5, 5, 8. So here we have 100 tens and units. Yes, 100 tens and units. So when we say 100 tens and units, these are the digits. Yes, and the number, the 100 here means 5 times 100. Yes, that's the position of those 5. Now for the tens, we have 5 times 10, then plus for the units, we have 8 times 1. So if you bring this out, you have 500 plus 50 plus 8. That will give you 558. So this is the number. Yes, so the number here is 558. Yes, but each of the numbers here actually represents, here we have the 100 digits, here we have the tens digits, and here we have the unit digits. So like I said from inception, today we are going to be looking at word problem leading to simultaneous equation involving tens and unit digits. So now we have some questions before us here. Yes, we have some questions before us. Now let's look at question number 1. Here they said the difference between the digits of a 2-digit number is 1. I take it again. The difference between the digits of a 2-digit number is 1. The number itself is 1 more than 5 times. Please look at this. 5 times the sum of each digit. If the unit digit is greater than the tens digit, find the number. Yes, find the number. So now, solution. Yes, we're actually looking at question number 1. Now, the difference in mathematics, when you hear difference, it actually means subtraction. Yes, like for instance, if I ask you the difference between 5 and 6. Yes, the difference between 5 and 6 can be 5 minus 6 or 6 minus 5. Yes, but when we say positive difference, it means the highest minus the lowest. Yes, the biggest minus the smallest. So in this case, when I say the positive difference is 6 minus 5, and that will give us plus 1. So in this case, we're told that the difference between the digits of a 2-digit number is 1. Yes, is 1. And coming to the last sentence here, it said if the unit digits is greater than the tens digit. Please, let's take note of that. The unit digits is greater than the tens digits. Now, solution. Let the number be xy. Now, let's take note of this. Let the number be xy. And if the number is xy, you discover that this is the tens digits, and here we have the unit digits. Yes, this is the tens, and this is the unit digit. So now here we said the unit digits is greater than the tens digits. So it means that the difference now will be y minus x. So y minus x now is equal to 1. Yes, let's look at it again. The difference between the digits of a 2-digit number is 1. And looking at this 1 is a positive value. That's plus 1. So it means this y is greater than x. The unit digit is greater than the tens digit, so it's 1. So let's call this equation 1. Yes, that's the first sentence there. Now they said the number itself. Now let's look at the number. The number itself is, now remember I told us that when you have a number 56, here we have tens and here we have units. The meaning of this is 5 times 10 plus units 6 times 1. The meaning of unit is 1. So that will give us 50 plus 6, and that will give us 56. The value you have there, the number. So it means the number itself if we are considering this xy, the number will be 10 in bracket x plus y in bracket 1. And that will give us 10x plus y. Yes, 10x plus y. Yes. So they said the number itself is one more than 5 times the sum of its digits. Now, this is the number. So the number 10x plus y is 5 times more than, yes, is 5 times the number itself is one more than 5 times the sum. Now, 5 times the sum will be 5 in brackets x plus y, because the digits here is x and y. So now they said is one more than this. Is one more than 5 times the sum of the digits. So it therefore means that here we have 10x plus y will be equal to, expanding this, we have 5x plus 5y. Then here we have plus 1. Yes, now let's collect like terms. Let's bring in 5x and 5y to the left hand side. It means here we have let me call it collecting like terms. Yeah, so when you collect like terms, we have 10x. When you bring this 5x inside to the left hand side, it becomes minus 5x. Then here we have plus y. Bringing this plus 5y here, it becomes minus 5y is equal to 1. So 10x minus 5x is 5x. 1y minus 5y is minus 4y is equal to 1. So now we can call this equation 2. Yes, so now you can see here that we have equation 1 and equation 2. That is a simultaneous equation. So now we are going to be solving the two equations simultaneously. Yes, we are going to be solving equation 1 and equation 2 simultaneously. So equation 1, we have y minus x. Y minus x is equal to 1. Equation 1. And equation 2, we have 5x minus 4y. Yes, minus 4y is equal to 1 as well. That's equation 2. Now, I want us to use the substitution method. Okay, so using the substitution method, yes. Now, in using the substitution method, you are required to pick one of the equations. Yes, you make one of the variables the subject. Thereafter, the variable you made the subject, you substitute into the other equation. So now in this case, I want us to pick equation 1. So from equation 1. Now our equation 1 is y minus x is equal to 1. Now let's make y the subject of the equation. Yes, so making y the subject implies isolating y, making y to exist alone. So in this case, we have y will be equal to 1 plus x. Yes, as you can see, we only have y here now. So it means we have made y the subject. So now let's call this equation 3. So here, we're going to substitute y is equal to 1 plus x into the other equation, which is equation 2. So it means anywhere we see y in equation 2, we are putting 1 plus x there. So it means now in equation 2, we have 5x minus 4 in bracket. The value of our y is 1 plus x and it's equal to 1. So it means here we have 5x minus 4 times 1 is minus 4. Minus 4 times x is minus 4x is equal to 1. So here we have 5x minus 4x minus 4 is equal to 1. 5x minus 4x is x. So we have x minus 4 is equal to 1. So it means x will be equal to 1 plus 4. So and the value of x is equal to 5. Yes, now we have seen the value of x to be equal to 5. Let's get the value of y. So let's substitute. Yes, substitute y is equal to 5 into equation 3. Yes, let's put it into this equation 3. And our equation 3, we said y is equal to 1 plus x. Yes, so it means y will be equal to 1 plus, the value of our x is 5. So we have 1 plus 5, which is equal to 6. So therefore, x is equal to 5 and y is equal to 6. Now, let's flash back. Remember we said let the number be equal to xy. Yes, we said let the number be equal to xy. So recall, Recall the number is x, y. Yes, it's x, y. So we're looking at x, y. Our x is 5 and y is 6. So the number is 56. Yes, the number is 56. So let's look at this if this is true. Let's see the unit digit minus the tens digit. So the unit digit is 6 and the tens digit is 5. So 6 minus 5 will give us 1. Yes, that's the first sentence. Yes, that the difference between the digits of the two-digit number is 1. So yes. So let's check for the second sentence. They said if the unit digit is 1, they said the number itself is 1 more than 5 times. So the number is 56. Let's see, it's 56. They said it's 1 more than 5 times the sum of the digits. That is 5 plus 6. So let's look at this if this is true. So 56, 1 plus, we have 5 in bracket 11. So that will give us 1 plus 55. And of course, you can see that this side is equal to this. So it therefore means that this question is solved. So that's question number 1. So we are going to be looking at question number 2. Yes, we are going to be looking at question number 2. Yes. So for question number 2, yes, for question number 2, they said in a 2-digit number, yes, in a 2-digit number, the sum of the digit is 8. Now let's call it AB this time around. Let's call it AB. Solution. Let the number be equal to, yes, be equal to AB. Yes, let the number be AB. Because we said it's actually a 2-digit number. So a 2-digit number is a number that actually has 2 digits. So now let the number be AB. Yes. Now in a 2-digit number, the sum of the digit is 8. The sum of the digits. So here we have, this is the tens digit, and this is the unit digit. So here they said the sum. So A plus B, the sum of the digits is 8. So let's call this equation 1. Yes. Now they said the difference between the number and the number with the digits the reversed. Okay, now let's see the number. The number is, we have 10A plus B. Yes, remember I told us that when you have 35, this is tens and units. So this is the same as saying 3 times 10 plus 5 times 1. So this AB is the same as 10 in bracket A plus B in bracket 1. That's tens and units. So here this is the number. Now now let's see the reversed number. Yes, the reversed number now will be BA. Yes, because we have it as the number is BA. So when you reverse the digits, it becomes BA. Yes, the number is AB. So when you reverse it, it becomes BA. So the number this time will be 10 in bracket, because this will now be the tens and this will be the unit digits. The tens digits now, and A becomes the unit digit when the digits are reversed. So that will be 10 in bracket B plus A in bracket 1. So that will give us 10B plus A. Now let's look at what they said here. Excuse me. They said the difference between this number, yes, that is the number now, 10A plus B minus. Now remember I told us from inception that difference in mathematics, yes, difference means subtraction. So the difference between the number, that's the number now, minus, okay. Now they say the difference between this number and the number with the digits reversed. So this is the number with the digits reversed. Yes, this is the number. So we have 10B plus A. Yes. Now they said is 54. So here we have 54. Yes. Now the question is, what is the number? So the number is AB. So we have to calculate for this now. We have to get this now. So now let's expand this now. So here we have 10A plus B minus 10B minus plus will change to minus. So here we have A, yes, minus A is equal to 54. So it therefore means that here, let's look at 10A minus 1A is 9A. B minus 10B is minus 9B. Now the whole of this is equal to 54. Now let's call this equation 2. Yes, let's call this equation 2. Now in this case, we are solving both equation 1 and equation 2 simultaneously. Yes, simultaneously. Now remember, our equation 1 is a plus b is equal to 8. That's equation 1. And equation 2, now we have 9a minus 9b is equal to, we have 54, equation 2. Yes. Now from equation 2, we can factor out 9 because 9 is common. So here we have 9 in bracket a minus b. Yes, a minus b will be equal to 9 will go into 54 6 times. Yes, because 9 times 6 is 54. Yes, 9 times 6 is 54. Or here we can say 9 in bracket a minus b is equal to 54. So now let's divide equation 2 by 9. Yes, by 9. So if you divide 2 by 9, we have 9 in bracket a minus b divided by 9 is equal to 54 all over 9. So this 9 will go with this 9. We'll be left with a minus b will be equal to 6. So this is the equation 2. Yes, it's the same thing. We only factor out 9 and divided both sides by 9. Yes. So now let's look at equation 1. Equation 1 we said is a plus b is equal to 8. Now this is equation 1. Now I want us to eliminate b. Yes, I want us to eliminate b. Now using the elimination method. Using the elimination method. Yes, using the elimination method. Now in eliminating b, now if you look at b very well, if you look at equation 2 and equation 1, here we have plus b. Here we have minus b. I remember I told us when treating the elimination method that when the signs are opposite, you add, you sum. Then when you have equal signs, you subtract. So like this case now, you have plus a here, you subtract if you are eliminating a. Then because we are eliminating b and 1 is minus, 1 is plus, we are adding. So now let's call it equation 1 plus equation 2. So if you add a plus a, that will give us 2a. Minus b plus b, that will go. So here we have 6 plus 8 is 14. So to get the value of a, we divide through by 2. So we have 2a all over 2 is equal to 14 all over 2. So this 2 will go with this 2. So we left it a is equal to 14 all over 2. And of course, we all know that 14 divided by 2 is equal to 7. Yes. So the value of our a is 14 all over 2, which is equal to 7. So let's get the value of b. So now let's substitute a is equal to 7 into any of the equations. Now let's put it into equation 1. So it means anywhere you see a in equation 1, we are putting 7 there. So equation 1 is a plus b. Now 7 plus b is equal to 8. So now the next step is to collect like terms. So when you collect like terms, we have b will be equal to 8 minus 7. So the value of our b will be equal to 1. So therefore, a is equal to 7 and b is equal to 1. Now if you look at this now, so the number ab now will be equal to, yes, because this is the number ab. So our a is 7 and our b is 1. So the number is 71. Yes, the number is 71. So now if you look at this now, they say the sum of the digits, 2 digits, is 8. So if you add 7 plus 1, 7 plus 1 is equal to 8. Yes, 7 plus 1 is equal to 8. Not there, please. 7 plus 1 is equal to 8. Now the next sentence, the difference between the number and the number with the digits reversed. So the number is 71. Yes, difference means minus. When you reverse the digits, you have 17. Yes, this 7 will go to the other side. That's the meaning of reverse. So 71 minus 17. That will give us 54. Yes. So this is the analysis. So that's question number 2. Yes. So now we are moving straight to question number 3. They say in a positive number of 2 digits. Now solution. Now let the number let the number be GH. Yes, let the number be GH. Now you can use any variable you want to use. Yes, so let the number be equal to GH. Let the number be GH. Now if you're dealing with GH, it means G is a tens digit and H is the unit digit. Tens and units. Yes, tens and units. So now they say in a positive number of 2 digits, the sum of the digit is 15. Yes, so G plus H is equal to 15. Now let's call this equation 1. Yes, G plus H is equal to 15. Now if the digits are interchanged, yes, if the digits are interchanged, now let's look at the interchanged digits. Interchanged digits. Yes, so when you interchange, you will have it as HG. Yes, so this now becomes the tens and the G becomes the units. Yes, so now they said if the digits are interchanged, the number is increased by 9. Yes, the number, remember the number is GH, is increased by 9. So what we're trying to say here now, this number is 10G plus H. This is the number. Yes, this is the number. So when you interchange it, this number, so when you add 9 to this number, it actually gives you the new number, which is 10H plus G. Now, I take it again. Yes. Now, they said, if the sum, they said in a positive number of 2 digits, the sum of the digit is 15. Now, we are saying let the number be GH, where G is the tens digits and H is the unit digit. Now, they said their sum is 15, so we have G plus H is 15. Yes. And remember, the number itself is 10G plus H. Yes. So the number will increase by 9 when you interchange. So it means when you add 9 to the original number, which is GH, it will give you the new number that you have actually interchanged the digit. So now it means in this case, we have 10G plus H plus 9 minus, here we have, yes, so here we have this now. We have 10H plus this. So it means in this case, what we're going to have will be 10G plus H plus 9 minus 10H. Yeah, this is minus 10H minus G is equal to 0. Yes, so 10G minus 1G is 9G. Yes, 1H minus 10H is minus 9H. Now plus 9 is equal to 0. Yes, plus 9 is equal to 0. It therefore means that here we have 9G minus 9H. Taking plus 9 to the other side becomes minus 9. Now let's call this equation 2. Let's call this equation 2. So if you look at this equation 2 very closely, you discover that 9 is actually common. So now I want us to divide through by 9 to reduce it, to reduce the value. So now divide equation 2 by 9. So when you divide this by 9, we have 9G all over 9 minus 9H over 9 is equal to minus 9 over 9. So this will go with this, will be left with G minus this will go with this, will be left with H is equal to minus 9 divided by 9 is minus 1. Yes, it's minus 1. So we can still call this equation 2 because we actually reduce the values. Yes. So now we are solving equation 1 and equation 2 simultaneously. So solving 1 and 2 using, yes, let's use elimination method. Yes, using elimination method. So in using the elimination method, it means that, yes, it means that here we have to eliminate any of the variables. Yes, and if you look at this, what we have here is G plus H is equal to 15 and G minus H is minus 1. So I want us to add, yes, add equation 1 and equation 2. Yes, add equation 1 and equation 2. So if you're adding equation 1 and equation 2, we have G plus G, that will give us 2G. Yes, we have H plus minus H, so the H is gone because H plus minus H is equal to 0. It means we have eliminated H. In that case, now we left it minus 1 and 15. 15 plus minus 1 is equal to 14. Yes, So 2g is equal to 14. To get the value of g, we have to divide through by the coefficient of g, which is 2. So we have 2g all over 2 is equal to 14 all over 2. So this will go with this. So g is equal to 7. Yes, g is equal to 7. Now let's get the value of h. So put g is equal to 7 into equation 1. And in equation 1, we have g plus h is 15. It means 7 plus h is equal to 15. So h now will be equal to 15 minus 7. H is equal to 8. So therefore, the number, remember we said let the number be GH. Yes, let the number be GH. And the value of our G is 7. So the number is G, which is 7, then H, which is 8. So the number is 78. So if you look at this number now, when you add the two digits, 7 plus 8, it will give you 15. Yes. And the number now, the new number formed, the new number will be 87 when you reverse this. Yes. So if you look at 87, now 87 is the old number, that is 78 plus 9. Yes. And that is why they told us here that if the digits are interchanged, the number is increased by 9. So the original number, which is 78, is increased by 9. So when you add 9 plus the original number, it gives you the number with the reverse digit. So thank you so much for listening. Remember to like, share with your friends, and also subscribe. God bless you.